So this video is all about solving equations using mental math. And before we can get into the actual work of solving equations, we have to do a quick review of the vocabulary surrounding them and remind ourselves exactly what an equation is. And an equation goes all the way back to expressions that we first started learning about earlier in the year. And there were two types of expressions that we saw. First, there were numerical expressions, ones that just had numbers and operations. So things like 2 plus 5, 3 minus 7 plus 12, etc., and variable expressions, which are basically numerical expressions, but there's a variable in there somewhere. So x cubed minus 7, 3x plus 7y plus 19, and so on and so forth. And equations can be built out of either numerical expressions or variable expressions, but they're most interesting when they involve a variable of some sort. So let's go ahead and look at the expression x plus 9 and ask ourselves the question, what would we need to be able to find one specific value for the variable in this expression? Now, of course, before we've practiced with just choosing a value arbitrarily and saying, okay, well, x equals 12. And in this case, then 12 plus 9 would be equal to 21. But what if we wanted to do it the other way, so that there was one particular value that the variable needed to have? What would we need to be able to find that specific value? Go ahead, pause the video, jot down some thoughts that you have, and come back when you're ready to move on. So in order to find a specific value for the variable in this expression, we would need to know the value of the expression in total. If we know what x plus 9 is meant to equal, then we can find what value x must have so that we can add 9 to it to get that value. And that's how we move from expressions into equations. The big difference between an expression and an equation is that an equation has an equals sign. If you see something mathematically that contains an equals sign, it is an equation. If you see something that contains no equal sign, no inequality signs or anything like that, just operations, numbers, and variables, then what you have is an expression. And an equation is what we get when we set two expressions equal to each other. So go ahead, pause the video, write down this definition of equation, come back when you're ready to move on. So now if we go back to the expression that we had for x plus 9, to make it an equation, we simply add an equal sign and some other expression to the other side. In most cases this year, when we're going to look at them, it's going to be just a single number. So we have a variable expression and we have a value for that one. We have one value for that expression. So in our case, x plus 9, we're going to say x plus 9 is going to be equal to the value 18. So the question that comes up then is, how are we going to be able to tell what the value for x is? And in order to think about that, we have to talk about what the equal sign really means here. And if we're looking at the equal sign, you've really seen it in three different ways before. The first place you've seen an equal sign is probably 2 plus 3 equals. There is a blank way back when you were in elementary school. This is the types of things where you first saw equal signs. It essentially indicated that the answer to the problem was there, or was meant to go there, and it was your job to fill in the answer. That doesn't quite work with the equation x plus 9 equals 18, because the answer, quote unquote, that we're looking for is actually the value for that variable. So we're going to have to think about the equal sign in some other way. Another way that we've seen the equal sign is to say, okay, x equals 7, and basically assigning a value to a variable. Now this sort of works when we're talking about x plus 9 equals 18. After all, the 18 is assigning a value to the expression x plus 9, but it's still not quite all the way there. It helps us understand what it is that we're actually saying, but we haven't actually gotten to the point of being able to solve the equation yet. What we need to think about is the equal sign in a third way. And that definition, essentially, for the equal sign is based on balance. It says that the two values, or the two expressions, on either side of that equal sign really are truly identical in value. If we imagine one of those old-fashioned scales where we have a plate on both sides, and we could take both sides of the equal sign and place one expression on each plate, the plate would be totally balanced because their values are identically the same. And this idea that the equal sign represents a balance of values. Two things really are truly entirely equal when their final value comes down to it is what's going to allow us to solve equations moving forward. And so if we go back to the equation that we saw here, x plus 9 equals 18, we know that the expression for x plus 9 and the numerical value 18 are identical. So we can think to ourselves, what value does x need to have so that we can add 9 to it to get 18? Well, one way you might think about solving that is to subtract 9 away from 18 to get 9. And that is what x is going to need to equal here in this case, because when we add 9 to 9, we get 18. That is the only value that can be plugged in for x so that x plus 9 really is 18. If we choose any other value, which we could say x is equal to 3, it would just make the equation false. And we're not after false equations, so we can make a false equation pretty much with anything else that we assign for the variable. We're looking for the one that makes it true. So now let's look at a few things for solving equations as some example problems, and then we'll give you a page of practice problems to work on. A few things that are we might see with equations. So the equation 3x is equal to 27 follows all those same notation rules that we talked about earlier when we had variable expressions. 3x is not 3 in the tens place and x in the ones place. It is 3 times the value of x. So we can think to ourselves, what do we need to multiply by 3 to get to 27? So if we divide 27 by 3, we should be able to get x equals 9. Similarly, you might see something like x over 5 is equal to 15. And in this case, the fraction bar, which is the way that we prefer to write division in equations, is telling us that x is some number that's divided by 5, and that quotient that we get is 15. So what number do we need to divide by 5 to get 15? That's very tempting, perhaps, to say, well, x equals 3, because 15 divided by 5 equals 3. But that's not the correct way to read this equation or the expression here. We need something that we can divide by 5 to get 15. So if we do a little quick calculation over to the side and find out that 15 times 5 is 75, we'll know that x will need to be equal to 75. And so that's a few different ways that you might see notation written in equations and some example problems. Go ahead, pause the video, solve these 6 equations right here. Find the value for x that makes the equation true. You can do it mentally. You can do some calculations. Come back when you are ready to see the answers and move on. So in the upper left-hand corner, we have 5 times x is equal to 25. In order to make that happen, x has to be equal to 5. So that's 25 divided by 5. In the middle on the top, we have x divided by 7 equals 12. Now we need some number that when we divide it by 7, we get 12. So 12 times 7 is 84. Therefore, x is equal to 84. And we can double check by putting 84 back into the equation. 84 divided by 7 is, in fact, 12. In the upper right-hand corner, x minus 14 equals 6. In this case, x equals 20 because 20 minus 14 is equal to 6. The lower left-hand corner, x plus 22 is equal to 40. The value we want there is 18. In the middle on the bottom, x minus 13 equals 19. The value we want there is 32 to be x. 19 plus 13 is 32. Therefore, 32 minus 13 is 19. And finally, in the bottom right-hand corner, 12 times x is equal to 132. If we divide 132 by 12, we get x equals 11. So that's about it. That's the introduction to equations. An equation is just what we get when we put two expressions equal to each other. That means that their values are really, truly identically the same. They are truly equal in value, and that the two sides of the equation are balanced from the point of view of values.